So Dr. Morrison is a professor and the director of the Forensic Data Science Laboratory at Aston University, while also working as a forensic consultant. His research has focused on forensic inference and statistics and forensic voice analysis. His diverse experience in forensic science includes many contributions, such as the associate editor for the journal Science and Justice, chair for the Forensic Science Committee of the British Standards Institute, member of the Forensic Science Committee for the International Organization of Standardization, or ISO, and the director of the Forensic Voice Comparison Laboratory at the University of New South Wales. Let's all welcome Dr. Geoffrey Stewart Morrison, and you can take it away, sir.
Thank you very much. So I have to start by saying I'm incredibly impressed by the talks yesterday and the talk that we just had this morning. And I am genuinely honored to be invited among this set of speakers. And I'm sure it will continue to be excellent after I've spoken. I'll say a little bit about myself because I think it's helpful to. I identify as a forensic scientist who uses statistical models and machine learning algorithms to solve problems in forensic science. So I'm not a statistician, I'm a forensic scientist, and I use these tools to try and solve forensic science problems. And I've done a lot of work in calibration and validation of systems that output likelihood ratios. And that work is applicable across many different branches of forensic science. I've done work in forensic voice comparison. I've done work in firearms. I currently have a PhD student who's working in forensic comparison of facial images. And here's the fun bit. I have a grant application under consideration that's in cell site analysis. And cell was one of those words that was mentioned yesterday. And all the biologists are thinking about cells. And it's nothing to do with the biologist cells. It's to do with where your mobile telephone is. So that's a little bit about me. What's the talk about? Well, the title says, what is the best way to present likelihood ratios? And I will start with the punchline. The bottom line is, I can't answer that question. I would love it if I could tell you the answer to that question. Unfortunately, I can't. And one of the reasons I can't is because the existing literature doesn't answer the question. It doesn't answer the question in a couple of ways, and one of the ways is that the existing literature hasn't really tried to answer that question. And the other way is that even the parts of the literature that seem to be relevant to that question have not come up with an answer. So I think that was the advice that we had from Dr. Burrell yesterday, is to start with your conclusion. So there it is, and you can all go home now. So I'm really interested in this question, and I think it's a really important question for us to answer. And so the first thing we did as the first step in doing this was to conduct a review of the existing literature and see what we can learn from the existing literature. And also from that, see what we might be able to apply, what we learned that we could apply to do future research that might help us answer that question. So, oh, hang on a second. Yep, there we go. Had to select the right screen. Okay, so a disclaimer, all the opinions that I express on my own, and the warning, I will express opinions. And funding, so this was partially funded by Research England. And I'm also going to start with an ad. I teach a course on concepts of forensic inference and statistics. This is a continuing professional development course. It's at master's level. The first word, concepts, is important. This isn't trying to make people into statisticians. This is designed for forensic practitioners, for legal practitioners. In fact, I have people who've taken this course who tell me that they're math phobic. They're afraid of math. And then they tell me that they have, not only have they understood the concepts, but they've enjoyed it, right? So if you are scared of math, don't worry. This is very gentle and focuses on concepts, not on trying to get you to work with all the formulas and use the numbers. But understanding the concepts is very important, I think, for forensic practitioners and for legal practitioners, that they're dealing with tools that are statistical tools and things like likelihood ratios. So if you're interested in this, the QR code is on the screen. It's delivered online, it's interactive, it's delivered over about 6 months. It requires about 1 day a week of commitment so that it's manageable by somebody who's working full time. Active learning, flipped classroom. Anyway, look it up if you're interested. Okay, on with the show. If you would like the slides that I'm showing you, you can get them here. I'll pause for a second if people are grabbing their phones to scan the QR code. And now I'm moving on. So if you're interested in knowing more about this, there is a paper that was published last year, and there's a QR code for that paper. It'll give you more details than I can present today. And I want to take this opportunity to acknowledge my co-authors, Agnes Bally, Christy Martiri, Becky Grady, and Bill Thompson. And they were a great help in getting this. And I'm a big believer in building interdisciplinary teams where different members contribute different skills and we can achieve something that none of us could achieve by ourselves. And so I think this was one of those sorts of teams. So here's an outline of where we're going. I've actually kind of already done that, steps 1 and 2, the question and step 1. We'll move on and I will talk about formats that have been used for presenting likelihood ratios. So I'll give you the definitions of them. I'll move on to the criteria for inclusion of studies in the review. What are the papers that we actually included? And then we start actually the review part by telling you about the formats that are actually used in the studies, the likelihood ratio values that have been presented in the studies, the evidence types like DNA, fingerprints, etc., some demographics about the participants, some information about the experiment design, and then I guess the core of the review is centered around different indicia of understanding. So we're looking at these things that have been used as indicators of whether people understood the likelihood ratio or not. And these are terms and concepts that have been developed by Christy Martiri and her colleagues in earlier work. And we're going to talk about 3 of these concepts. One is sensitivity, the other orthodoxy, and the final one, coherence. I will define them when we get to them. Something to note, if you do have a background in statistics, these terms don't mean what they mean in statistics in this context. So they will be defined. As I go along, I will make comments on methodology, right? So there's not a separate section here, but I'm going to comment on it as we go on. So back to the question. This is a slightly longer version of the question that I'm asking, and it's what is the best way for forensic practitioners to present likelihood ratios so as to maximize their understandability for legal decision makers? And why are we asking this question? Well, because it's widely agreed that the likelihood ratio is, the likelihood ratio framework is the correct way for forensic practitioners to evaluate strength of evidence. So starting with that premise, the problem is therefore, how do we communicate those? And we need to communicate them to legal decision makers. So this can include judges at an admissibility hearing, or judges or jury members making decisions during a trial. It could involve prosecutors or defense attorneys making pre-trial decisions or recommendations. A lot of the existing literature has been agnostic with respect to the way that, to the evaluation of the forensic evidence. So a lot of the existing literature would just research what's actually being done, things that are being presented. So you have, for example, you might have studies that look at likelihood ratios, but they would also look at posterior probabilities or categorical decisions and include them because people are using them. So I'm specifically focusing on this starting point that the likelihood ratio is the correct thing for the forensic practitioner to do to evaluate the strength of the evidence. So our problem is how best to communicate that. Okay, and as I said before, step one, let's conduct a review and we'll see what we already know and what we still need to learn. So formats for presenting likelihood ratios. So the first thing is to understand what a likelihood ratio is. It's the probability of the evidence given one hypothesis divided by the probability of the evidence given an alternative hypothesis. And those two hypotheses must be mutually exclusive. If one is true, the other must be false. And all the literature that in the review are using source level hypotheses. So H1 in this example is always going to be some form of same source, and H2 is always going to be some sort of different source hypothesis. Okay, so that's the background. That's what we're trying to communicate. What formats are used to communicate that? Well, one way is a numerical likelihood ratio. So for example, the observations are 1,000 times more probable if H1 were true than if H2 were true. Another format in which likelihood ratios have been communicated numerically is a random match probability. So for example, the observations made on the question source item and the known source item match. The probability of observations made on an item randomly selected from the relevant population matching the observations from the question source item is 1 in 1,000. So if you're working in DNA, you're probably used to this. It's kind of the traditional DNA model before the detection limits got better, and now everything has contamination or is a low template or is a mixture. This was the traditional kind of DNA way of doing things. It depends on the data being discrete and invariant. So that means the values have to be some discrete values. It could be 1, 2, 3, 4. It can't be 2.5. It can't be 1.9. It would have to be a discrete value, and then it would have to be invariant. So, for example, if we have nice high template DNA, we assume no contamination, no drop in, no drop out, no ambiguity as to whether a peak is allelic or stutter, and no problems like that. And then if we look at the DNA profile and we have the DNA profile from the suspect, the DNA profile from the defendant, if they match, if they're all of the numbers, all of the alleles are exactly the same, then the probability of getting that profile on the question source DNA profile, if it came from the suspect, is 1. If one of those numbers is different, then that probability is 0. Right, and that can only be true if the data are discrete and invariant. And then that gives you the numerator for the likelihood ratio. And so you now just have to worry about the denominator, which is the random match probability. So a random match probability is a special case of a likelihood ratio, but it only works under particular conditions. So the problem is that most branches of forensic science, the stuff you're measuring is continuously valued, has within source variability, and now in DNA, this model doesn't work anymore because you're looking at DNA mixtures, you're doing probabilistic genotyping, and it's not the case that the numerator is either 0 or 1 anymore. So other ways, those were both numerical ways of presenting likelihood ratios. There are also verbal ways of presenting likelihood ratios, and the first one is a verbal likelihood ratio. And if you look at this one, it says the observations are much more probable if H1 were true than if H2 were true. And if I flip back to the previous slide, you see that that's an exact match, except for we've substituted 1,000 times more probable for much more probable. So we've substituted a verbal expression for a numerical value, right? But the format is still the format of a likelihood ratio. So another way that people have proposed that likelihood ratios be presented is a strength of support statements. And here's a couple of examples of strength of support statements. The observations provide strong support for H1, the same source hypothesis, relative to H2, the different source hypothesis. Often these have also been presented as with only one hypothesis mentioned. So observations provide strong support for H1. There are people who vehemently argue that these are likelihood ratios. I disagree. I don't think these are likelihood ratios. They do not have the form of a likelihood ratio. So they don't give you the probability of the evidence given one hypothesis versus the probability of the evidence given another hypothesis. To me, these look more like posterior probabilities, right? But we're going to include them in the review because there are people who argue that these are likelihood ratios. I told you I would express opinions. So these verbal expressions are often arranged into what are called verbal scales. And in the verbal scale, you have different ranges of likelihood ratio values. And then for each range of likelihood ratio, there is a verbal expression associated with it. And so you get a scale like this. Some of my problems with these is the ranges are arbitrary. The verbal expressions that relate to the ranges are arbitrary. To decide that more probable means a likelihood ratio between 10 and 100, that's just specified by this table. There's nothing intrinsic about that. And then there's the problems. Do people actually understand? When you say more probable, do people understand that as being equivalent to a likelihood ratio between 10 and 100? The only way you could actually define, tell them that would be you'd have to, show them the table. So you get back to having to have the numbers. I'm also not a fan of having these predefined verbal expressions. And I'll give you an example. I once did a case, it's a forensic voice comparison case. And in that case, I calculated a likelihood ratio of 8. And 8 doesn't sound very high. And using this table, it would be the observations would be slightly more probable if H1 were true than if H2 were true. But if I tell you that in this case, we had video on the context, and it's clear that it's either person A or it's person B. So if it's either person A or person B is a likelihood ratio of 8, are people going to interpret that as slightly more probable, or would they think it's would they verbally think it's something stronger than slightly more probable? So there are problems with this, that different people will interpret the same words differently, and the same person will interpret the same words differently in different contexts. So I'm not a fan of these. Okay, so criteria for inclusion in the study, in the review. It had to be a primary report of empirical research, so not another review study. And it had to test layperson understanding of likelihood ratios. And by layperson, I mean not statisticians, not forensic statisticians. And it had to include a numerical likelihood ratio. So they had to be presented to participants. It could also include some of these other formats, but a necessary requirement for inclusion was that it had to present a numerical likelihood ratio. One of the reasons we did this is to guarantee that the study is actually interested in communicating likelihood ratios. There's a lot of papers out there that include research in which participants are asked to give responses to random match probabilities. But in those studies, and lots of those studies, there's no acknowledgement in those studies that random match probabilities are a special case of likelihood ratios. And I think often they're being presented just because it's something that gets presented in practice, and that's why it was included. So those are the criteria necessary for inclusion. And based on that, we found 17 papers in total. And they go back over 30 years. We didn't have a cutoff for the year, just the first one we found was 1996. And the first one is by Jay Kohler, who will be up next after the break. And you might notice some of my co-authors' names, they appear multiple times in the list. And full disclosure, the last one, Thompson et al. 2025, I'm a co-author on the last one. So 17 papers total. Some of those papers had multiple experiments in, and it made it easier to do the analysis if sometimes in the multiple experiments we count it as different studies, right? So I'm going to move on, instead of talking about papers, I'm going to talk about studies, and there was a total of 22 studies. And so by design, we had 22 studies, and they all presented numerical likelihood ratios. 12 of them also presented random match probabilities. And here was something that I was surprised by: the verbal likelihood ratios, 0. None of these studies presented verbal likelihood ratios. However, you did have the support statements. If we add these together, there were 12 studies that, as well as presenting numerical likelihood ratios, also presented support statements. Interestingly, it appeared that single hypotheses seemed to be more common than two hypotheses. Okay, across these studies, these are all the different values of likelihood ratios that were presented. So as you can see, there's quite a range. Most of the studies presented 2 likelihood ratio values. A few only presented 1. A few presented more than 2. Almost all of the studies presented likelihood ratios which were greater than 1, in the sense of the probability of the evidence was greater if the same source hypothesis was true than if the different source hypothesis was true. So the ones over here that I've said are less than 1, they weren't actually presented as numbers less than 1. They were presented as numbers, but the probability of the evidence was greater if the different source hypothesis was true than if the same source hypothesis was true. Okay, moving on. Different evidence types. DNA. Hey, DNA is popular. That got presented more than anything else. And then the next most popular were fingerprints and footwear. And some of these studies would present 2 things, like they'd present DNA and footwear. And so we have comparisons between those. Demographics for participants. We've got university students, general community, jury eligible community. I'm not sure if this really makes a big difference from even the jury pool members. There might be a difference from former juries. It was difficult to sort out between jury pool members and former jurors. So that could be a question: do former jurors behave differently from people who have not had any jury experience? And the last set was criminal justice professionals. Again, we couldn't easily sort out from what was presented in the studies. Some of these were forensic scientists, some of them were lawyers. Right, but you notice that's a small number. If we were looking for lawyers, who's the group that we actually perhaps most care about, not very many of those the studies have studied lawyers. Experiment design. So the experiments involve presenting a likelihood ratio in some format to participants, and then eliciting a response from the participants. And some of them would elicit a response before presenting the likelihood ratio and a response after presenting the likelihood ratio. And so these are the different formats that have been used to gather those responses. And we have odds. So prior odds, posterior odds, trying to elicit prior odds, trying to elicit posterior odds. More common was eliciting probabilities, prior probabilities or posterior probabilities. And these were always elicited as numbers between 0 and 100. So they're percentages. I see a problem with eliciting percentages compared to eliciting odds. So if you think about an odds of 100, that's a probability and a percentage of about 99. Odds of 1,000 is a percentage of about 99.9. What if we go up to 1 million? That's a probability of 99.9999. I'm suggesting that we're not going to get participants making distinctions on multiple points of 999, whereas it's easier to, so you end up with a kind of ceiling effect. You're going to get a ceiling effect, which you're not going to get with odds. And so that may limit, if you've got you'd also have a floor effect. So you might get a limit because of a floor effect on your priors and a ceiling effect on your posteriors as to how much the participants' beliefs can change in terms of probabilities. We also had responses elicited using multi-level scales. So these are scales that have a start and an end. And in between the start and the end, they have levels. And on each level, there might be numbers or words presented, or numbers and words. A problem I see with this is because the scale is finite, there's a number and end, it suggests that the top and the bottom level, that's as strong as you could get, or that's as weak as you could get. Whereas it's not true for odds. Your odds can go on to infinity. Also, I think what it tends to do is rather than participants necessarily looking at the numbers or the words on the levels and trying to interpret them, instead they use the scale as a relative position on a scale. And so I'm suggesting that if you change the numbers or change the words on the scale, it wouldn't have an effect on the position on the scale that participants were choosing. Right, so I'm not convinced that it demonstrates that they understood the words or the numbers. I'm also questioning whether it's something that would be could be used in court. Can you give the jurors or the judge a scale and say, use this? I'm doubtful of that. So traditional experiment design, was it within participant, between participant? And what this means is, did I have one group of participants who got one likelihood ratio value and a different group who had a different likelihood ratio value, or one group who had one format for presentation and another group who had a different format for presentation? Or did I have single individuals and I tried to present them, each individual got multiple different likelihood ratio values on multiple different presentation formats? You can see that the between participants was much more common. I think the within participant is very difficult to do, and there's potential problems. It's like if you've been presented with one format, does that influence how you understand the next format? So those are often people think within participant designs are better. I think there's some practical problems with it here. I mentioned before studies that would elicit prior probabilities or prior odds, present the likelihood ratio, then elicit the posterior odds or posterior probabilities. So most of the studies did that within participants. So the same participant gave you the prior odds and the posterior odds. There was a couple of studies that had different groups, and what they did is, for example, one group just got the case information and didn't get the evidence, didn't get the likelihood ratio, and another group did get the likelihood ratio. So that first group was used as the prior for the second group. I think there's some philosophical problems with that, as that the priors were different, and then you end up having to use the average of the first group's decision and then compare it with the average of the second group. So I think that first same participant for priors and posteriors is a better methodology. Almost all of these studies were exclusively written. And a lot of them, in later years, a lot of them are done online. A couple of studies, one did live and one did video. In common law jurisdictions, evidence is usually received by judges or by jurors in oral format. So I think this is an important thing to include. There are, of course, jurisdictions where it is principally a written format, but if you're interested in what happens in common law jurisdictions, I think it's important to include live or video. Video is probably easier to control if you have then multiple different groups or individuals looking at it. And this participants in all of the studies responded as individuals. So this might be akin to a situation where a judge is making a decision. None of the studies had groups of collaborators, so that they were presented with the evidence and then they discussed and jointly came up with a decision about what it meant, right? Which is what you would expect for juries. So all of the studies were about individuals, so they may be more relevant to what judges do. None of the studies are necessarily relevant to how a jury acts. So as I said, this is the core. If we think about the indicia of understanding that have been used in these studies, and the first one we're going to discuss is sensitivity. And participants' responses are sensitive if they reflect relative differences between the presented likelihood ratios. So if you have two likelihood ratios presented, let's say imagine it's different groups. One group gets a larger likelihood ratio, you elicit the posterior odds. Another group gets a smaller likelihood ratio, and you elicit the posterior odds. Then the posterior odds for the first group, if they are larger than the posterior odds for the second group, then that's counted as demonstrating sensitivity. So it's not measuring by how big the difference is, it's just, is there a difference in the right direction? So does a larger likelihood ratio get interpreted as greater strength of evidence than a smaller likelihood ratio? So there were 15 studies that used sensitivity as an indicium of understanding. With the exception of 2 studies and a few conditions in other studies, all the studies found that participants were sensitive. And this was true across all of these, across formats, across response types, across evidence types, which means actually it's not very helpful for answering our question. If participants all appear to be sensitive, maybe that doesn't help us. I would also argue that maybe sensitivity is a pretty low bar for understanding. We actually, when we looked at this, we did a bit of a meta-analysis, and we included the exceptions, and we included the studies which presented more than 2 likelihood ratios. And we discovered that there were exceptions when more than 2 likelihood ratios were presented. And based on that, we developed the following hypothesis, is that somewhere, and based on the results, between about 100 and 450, a likelihood ratio of 100 and 450, there's a threshold. And if you present to participants a value that's below the threshold and a value that's above the threshold, so on this, for example, if you presented something, one of the blue ones and one of the red ones, then participants appear to be sensitive to the difference. However, if you present them 2 values that are below the threshold, so the 2 blue ones, for example, or the 2 red ones, then they don't show sensitivity to the differences. Right, so this conclusion on the previous slide that, hey, most of the studies found participants are sensitive, maybe that was an accident. The fact that most of the studies presented two likelihood ratios, and one happened to be low and the other happened to be high, above and below these thresholds. So obviously, to do more research to test this, we would need to present multiple likelihood ratios that are below the hypothesized threshold and multiple likelihood ratios that are above the hypothesized threshold. This is obviously, if this is true, this is obviously bad news if you want people to understand likelihood ratios, because it actually kind of suggests that they don't really, it's just some sort of threshold value, not a gradient result. Okay, as I said, sensitivity seems to be a pretty low bar. Orthodoxy is a higher bar. And what orthodoxy means is if participants' responses are orthodox, if they reflect use of the values presented, or the likelihood ratio of values presented, to update priors to posteriors as per correct application of Bayes' theorem. So in Bayes' theorem, the posterior odds equals the prior odds multiplied by the likelihood ratio. So in our experiment, if we elicit the participants' prior odds before we present the likelihood ratio, we then elicit their posterior odds after we've presented the likelihood ratio, and then we divide the prior odds by the posterior odds, we end up with their effective likelihood ratio. And then what we can do is we can compare their effective likelihood ratio with the presented likelihood ratio. And if their effective likelihood ratio equals or is very close to the presented likelihood ratio, then their responses were orthodox. So we had 14 studies that used orthodoxy as an indicium of understanding. And here's the bad news. And actually, this is, I think, prefigured in the earlier talk today. The average effective likelihood ratios were always weaker than the presented likelihood ratios. And in many cases, they were much weaker. So for example, likelihood ratios of 1 million were presented, but the effective likelihood ratio was less than 10. And this was true across all formats. So actually, it doesn't really help us know if one format is better for presenting likelihood ratios to get understanding or not. So here are graphical representation of some results. So these are all average values, their means or their medians, depending on what we could get out of the study. So that's a limitation. They're average values, but they're we'll see what we get out of this. The x-axis is the log 10 of the presented likelihood ratio. The y-axis is the log 10 of the effective likelihood ratio. So if participants were orthodox, and on average they were orthodox, then all of these samples would lie along this diagonal line. And pretty clearly you can see that none of these symbols lie along that diagonal line. And in fact, what's happened is all of the symbols are closer to a log likelihood ratio of 0, i.e. a likelihood ratio of 1, than the presented likelihood ratio. And in fact, you can probably see that most of them are pretty close to that line. You might also notice that there are some that appear to be better than others, and the things that stand out are over here, and they're over here as well. The 5-pointed stars. And the 5-pointed stars are from a study here. And this study presented evidence which was purportedly DNA evidence, and also used elicitation of results, responses, using one of these multi-level scales. And as I suggested before, I think what might be going on here is that they're not actually interpreting the numbers or the verbal expressions, but they're using the scale. And the interesting thing to see here is the 6 pointed stars are also using the eliciting using the multi-level scale for the responses. But the participants were told that this isn't DNA evidence, they were told it was footwear evidence. And so the 6 pointed stars are there and they're down there. So the same likelihood ratio values presented, either verbal or likelihood ratios or random match probabilities, the same, but the same values presented. When participants are told that it's DNA, they pick more extreme values on the scale. And when they're told that it's footwear marks, they pick values closer to the middle on the scale, more conservative values. So again, I think what's happening is you could say maybe participants think that DNA evidence is more valid or stronger than footwear evidence. And so that's why they're picking these more extreme values on the scale, right? So they're not interpreting the same words or the same numbers the same because it's being interfered with by perhaps their beliefs about DNA compared to their beliefs about the validity of footwear comparison evidence. I think we saw, I think on some of the slides yesterday, we saw some similar results. So those were all based on averages. So we have a couple of studies in which we had access to the raw data. So this one is from Bali et al. And we've got numerical likelihood ratios, numerical random match probabilities, and verbal support statements. And in this study, the presented likelihood ratio was here. It's a likelihood ratio of 100, so it's a log 10 of 2. And so if the participants were orthodox, they would all be on that line. And you can see that, in fact, most of them are substantially below that line. And you don't even see a bulge in the violin plot at that line. And in fact, in that one, there's nobody was there. You do see bulges, you'll see a bulge, for example, you'll see bulges in all of them. You'll see bulges there, which is a likelihood ratio of 10. I think these ones are probably likelihood ratios of 2. And you've got a few that actually went in the wrong direction. Right, so no evidence of orthodoxy here. Another study, so this is Thompson et al. 2025. This is the last one, the one I said I was involved in. In this one, this was the one where we presented forensic voice comparison evidence, and we presented it using video. And we included a condition in which in the video there was an explanation of the meaning of likelihood ratios. So actually a lot of the existing studies just present these things and give no explanation of the meaning of a likelihood ratio. So it's kind of unsurprising that people don't understand when there's no explanation. So we thought, let's give them an explanation. And so I played the part of the forensic practitioner, and Bill Thompson played the part of the lawyer. And I'm a forensic scientist who's testified in court on forensic voice comparison, and Bill is a lawyer who has examined expert witnesses in court. So we thought we had kind of a good level of face validity there. The explanation involved a set of scales, a balance. And we said, if your prior odds give you that many weights on this side of the scale, that many weights on that side of the scale, and then you get a likelihood ratio, and what you do is you then, your likelihood ratio is 4, so you multiply the number of weights on this side of the scale by 4, and then after that, then your scales look like this. You've got that many weights on this side and that many weights on that side, and those are your posterior odds. So that was the basis for the explanation. So, and our interest is does that improve understanding in terms of orthodoxy? So in this graph, you can see that there was sensitivity. So when the presented likelihood ratio was 30, compared to when it was 3,000, we got sensitivity. So the solid black lines are where 30 and 3000 are in the log 10. So we did have sensitivity. You can see that these violin plots go higher when the likelihood ratio presented was 3000. Did the explanation, so the blue shading is given the explanation, the red shading is with no explanation. Did that help? Not immediately obvious. You might look here, for example, you might look at these two, and you now see in the blue one where the explanation was given, you now see a bulge at the value of the, so the effective likelihood ratio is the same as the presented likelihood ratio, where there wasn't a bulge when there was no explanation. You can look at the others, it doesn't make a difference. One of the problems, so actually one of the things to notice, a lot of participants had effective likelihood ratios of 1. And another problem we had was a lot of participants had prior odds of 1. So we did do some statistical analysis to look at this. So what we had to do is exclude participants who had prior odds of 1, because we don't know if their effective likelihood ratio equals the presented likelihood ratio. Is that because they understood the meaning of the likelihood ratio and a correctly applied Bayes theorem, or did they commit the prosecutor's fallacy? So we removed participants whose responses had prior odds of 1, and after that, given the explanation, about 3% of participants gave orthodox responses, i.e. their effective likelihood ratio equal to the presented likelihood ratio, and less than 1% for those who were not given the explanation had orthodox responses. We calculated a Bayes factor, and we discovered that these data were 3 times more likely if the value given the explanation was larger than if there was no difference between irrespective of whether an explanation was provided or not. So we got a Bayes factor of 3, and you might take that as encouraging. Yeah, okay, so I think there was an effect. However, when you look at it, even if there was an effect, your ultimate result was 3%. So yeah, in a practical sense, did that work? Not really. So this is very discouraging, because I'm somebody who thought, I believe in likelihood ratios, and surely if we explain them, that will help. Not really. Some caveats. There were some of these studies elicited offense level. So they presented source level likelihood ratios, but they elicited offense level conclusions. They asked guilty versus not guilty instead of asking the same source versus different source. So, a participant might have a very different posterior odds at offense level than they have at source level, because of course they're going to combine other stuff that's been presented to them in the case. On a similar vein, a lot of the studies had lots of case information, lots of extraneous information that I feel was unnecessary, to the point where I think in some cases participants had already made up their mind on the basis of the case information that was presented. And so if you've already made up your mind and now you get a likelihood ratio, maybe there's not much more room for you to increase your odds. Right, so that could be an explanation for why there's not a lot of increase. Also, participants may have done something that they may have weighted the likelihood ratios based on other information. And for example, as we discussed earlier, when they were presented with DNA versus footwear, maybe they weighted their responses based on their belief about the validity of DNA evidence versus their belief about footwear evidence. Or it could be, could be something specific to the particular testimony that was presented, whether the expert was wearing a tie or not, that might have, affected what, how valid they thought the testimony was, and they may have weighted the testimony based on that. And although you may not think that this is orthodox from a Bayesian perspective, it would seem to me to actually be a rational thing to do, to kind of, it's to reweight the presented likelihood ratio, and now that's not the presented likelihood ratio for the prior effect is the evidence, and now the forensic scientist, the prior effects likelihood ratio is their likelihood ratio based on the presented likelihood ratio of the evidence. So, and that might be smaller than the presented value. So these are factors which may have influenced the results. So the last indicium of understanding that's used that we're going to talk about is coherence. And participants' responses were counted as coherent if they reflected logically correct interpretation of likelihood ratios, i.e. if they indicated that participants had avoided reasoning errors and logical fallacies. And I'll give you a couple of examples of reasoning errors and logical fallacies. And those are the weak evidence effect and the prosecutor's fallacy. And I'll explain and talk about each of these. So 14 studies used coherence as an indicium of understanding. We'll start by talking about, there were others, but we're just going to talk about these two. So the weak evidence effect occurs when in a support statement such as weak support for H1 is interpreted instead as support for H2. Or a numerical likelihood ratio that's a little bit larger than 1 is interpreted as if it were a likelihood ratio that's less than 1. So this is a subset of the data that I presented earlier. And it's a subset from the studies that looked at the weak evidence effect. And the weak evidence effect was most common for the verbal support statements. So in this plot, the verbal support statements are colored green, and you can see that there's several green triangles that are here. So they are weak support, or actually going up to the next level. I can't remember what it was, and 64% of participants interpreted these verbal expressions as stronger support for the different source hypothesis, even though they were intended to be communicating support for the same source hypothesis. So interestingly, when the whole of the verbal scale was presented, and that gets you the cyan, there's just 2 here. That gives you the cyan triangles. When the whole, so it's a verbal statement, a verbal support statement, and the whole verbal scale is presented, then that alleviated the weak evidence effect. It went from 64% to 32%. So numerical likelihood ratios, random match probabilities, they also had occurrences of the weak evidence effect, but it was much, much more common for the verbal support statements. Interestingly, also, there was a study that included likelihood ratios here, that the log likelihood ratios here are less than, the presented values are less than 0 as log likelihood ratios, i.e. the probability of the evidence was stronger given the different source hypothesis than given the same source hypothesis, and the weak evidence effect was not common that way, right? Some of these results may be due to participants being confused or not paying attention. So that has to be taken into account. But when you've got 64% of them doing it, it's not just people being not paying attention. So the other coherence factor we're going to look at is the prosecutor's fallacy. And the prosecutor's fallacy is interpreting the likelihood ratio as if it were the posterior odds. So it's ignoring the likelihood ratio or assuming the likelihood ratio is 1. So there were 2 different research designs where we got information about the prosecutor's fallacy. And the first one is spontaneous occurrences of the prosecutor's fallacy. So we had a presentation, or we had an elicitation of prior odds. We presented the likelihood ratio. We listed posterior odds. And we discovered that the posterior odds equals the likelihood ratio, right? And that just occurred spontaneously in that experiment design. And the other experiment design that looked at the prosecutor's fallacy presented written statements. And participants were basically asked, is this written statement correct, or is it erroneous? For example, earlier you were presented with a likelihood ratio. Does this written statement correctly represent what was presented to you before? And so they were asked to make decisions on these written statements. And in that context, you had some really big errors of participants being presented with a statement that included the prosecutor's fallacy and saying it's fine. The good news is the spontaneous instances of the prosecutor's fallacy were relatively low. So I think that maybe they're lower than people fear. They get into the teens, so that may still be of concern, but they're not into the 70s, 80s, and 90% error rate. So we think, in fact, some of the original authors have explanations for this, and they think what's happening is maybe participants are seeing a written statement that's superficially similar to what was presented to them before. And because it's superficially similar, they say, yeah, that looks like what was presented to me before. And they're not really focusing in on the differences and seeing the differences. And one strengthening factor for that is there was one study that presented, so some participants were presented with numerical likelihood ratios, and other participants were presented with numerical random match probabilities. And then later were presented with two different sets of prosecutor's fallacy written statements. And in one statement, it was expressed in odds, so it was more similar to the likelihood ratios. And in the other set, it was presented as natural frequencies, 1 out of 100. And participants who were presented with the numerical likelihood ratios made more errors on the odds stated form of the prosecutor's fallacy, and participants who were presented with random match probabilities made more errors on the natural frequency presentation of the prosecutor's fallacy, which again is extra evidence to suggest it was like the superficial similarity with what was previously presented to them. By the way, again, all of these studies were all done in written format. If you're interested in the ones at the bottom that are better, the lowest one was actually the mixture of forensic practitioners and lawyers, and this red one up here was forensic science students. By the way, here's come and take my course that I told you about at the beginning, and if you pass my course, you're going to be somewhere down at the bottom in the, I'm not guaranteeing you'll never commit the prosecutor's fallacy, but you're going to be in the very low percentages. So we took the data from Thompson et al. And we looked at that, and so we took away the versions where the prior odds were 1. We look at posterior odds equal to presented likelihood ratio. Here are the data. We calculated a Bayes factor, and it turned out that the probability of getting these data, if there were no difference, is 1.5 times higher than if the value given the explanation were lower. So we have no evidence that presenting the explanation of the meaning of likelihood ratios helps people to avoid committing the prosecutor's fallacy. As I say, disappointing. Okay, conclusion. Results from the published studies suggest that understanding likelihood ratios is poor, irrespective of the presentation format, irrespective of whether an explanation is provided. I didn't really talk about it, but some studies presented tables or graphs for converting from prior probabilities to posterior probabilities. They didn't help. One of the problems may be that they were actually probabilities, they weren't odds. And the provision of a verbal scale didn't really seem to help, except in avoiding the weak evidence effect. There's not a lot of research done on that, so there could be some more work done on that. But if I went back, I would show you that just the numerical likelihood ratio by itself worked equally as well or better than presenting the support statement plus the whole scale. As I mentioned at the beginning, most of these studies were not designed to answer our research questions. So there's they weren't trying to answer it. And irrespective of whether that creates a weakness with respect to answering our question, a lot of these studies had weaknesses in research design. So those are the caveats for the results. Oh, by the way, I'm going to include in those weaknesses in research design, I'm including the Thompson et al. 2025, in which I was a co-author. And we acknowledge weaknesses in that research design in the original paper. So what are we going to do in the future? Well, I want to do more research to actually try and get a better answer to this question. What is the best way to present likelihood ratios? I think if anybody's interested in working with me on this, please look me up on the internet. I'm easy to find. Send me an email if you're interested in collaborating or contributing. I'm interested to hear from you. I think what we need to do is a more systematic series of experiments. I think we need to present numerical likelihood ratios. I think we need to present multiple values both below and above the hypothesized threshold that we mentioned before with respect to sensitivity. I think we need to include likelihood ratios that are greater than 1 and less than 1, i.e. probability of evidence is greater if the same source's hypothesis is true than if the different source's hypothesis is true, and probability of evidence is greater if the different hypothesis is true than if the same source hypothesis is true. I think if we're interested in common law, we need to do video presentations. Better explanations with a question mark, because that's the $64,000 question. But I was really encouraged by the presentation, some of the presentations yesterday with ideas about how to present things better. We want to avoid explanations. So the explanation we give included an example in which the prior odds were 1. I think we want to exclude that because that might be promoting the prosecutor's fallacy. I think to demonstrate that this really is good, strong, solid evidence we're presenting, we need some description of the method and of validation results. So I think we want to get closer to ecological validity in the sense of what happens in court. Validation results might be something that gets presented in court. I think we want minimal case information because we want to avoid contamination. So my PhD supervisor said, clean your test tubes. We want to try and have scenarios that we avoid listing prior odds of 1 so that we can tell the difference between correct application of Bayes' theorem versus prosecutor's fallacy. I think we want to elicit prior odds and posterior odds, not prior probabilities, posterior probabilities, or scales, multi-level scales. I think we want to explicitly ask participants, what was your elicit what their posterior odds, but then ask them, if you had applied Bayes' theorem, what would the posterior odds be? Because, they may say, yeah, but I used something weaker because I don't believe footwear evidence can be that strong, right? So actually ask them about that. I think we need to include some proctored experiments where somebody is on hand and observing the participants. We can get lots of information doing online experiments, but we probably have a lot of noise because some people aren't really paying attention. I think we'll do some of that because it's cheap and fast, but I think we need to get to doing some proctored experiments. I think we need some experiments using actual legal decision makers, judges, maybe lawyers, maybe former juror members, and I think we need to do experiments where we're using collaborative groups who listen to and then debate and come up with their final decision together, because that reflects jury decision, and that occurs in common law jurisdictions. So if we're interested in that, nobody's done that before in this context. So Thank you very much.
Thank you very much for that, Dr. Morrison. That was an excellent presentation. I really appreciate the rigor of the approach you took to kind of pulling all these different studies together. The conclusions are a little grim.
Yeah.
Maybe not inconsistent with what Dr. Gigerinzer, excuse me, discussed in the previous talk, of just the difficulty to understand conditional probabilities and likelihood ratios. So what's the way forward, given the difficulty in understanding?
So, look, I mean, I should say from the offset, I'm really invested in likelihood ratios. I've talked about there's a paradigm shift, and likelihood ratios part of that paradigm shift. It's from my perspective, it is the correct thing to do, and I'm not a minority among experts in forensic inference and statistics. That's the majority opinion. So I'm an advocate for this, and I think the problem is, how do we communicate it? I think there were some ideas discussed yesterday about better presentation, and earlier this morning about perhaps better ways to present them. So those could be things that we include in future experiments. I think we need a series of experiments, and I think we want to see, like, what are the good ideas about how to try and communicate this, and I think that's the way forward, is to do that. I think a problem is, as I say, I'm not a fan of the roller scales. And in part, empirically, they don't seem to help. I mean, they were proposed as a way to help communication, but empirically, they don't seem to help. Although I'm not a fan of those, I might say, okay, can we present a numerical likelihood ratio and also the verbal scale? Does that combination help? But I think we need, a concerted research program on that. I think there's a lot of diversity in the research in terms of methodology and participants and values presented and formats presented, and it's not really very coherent. And 17 studies over 30 years is not a huge number of studies. So I think, we need a more systematic, more concerted, and I'd like to, and then hopefully maybe in 4 or 5 years, I can come give you another presentation and tell you, this is the way to present likelihood ratios. That's my hope. It could be, but of course, it could be that we do this and we might discover it's still hopeless. That's science. So.
Yeah, sometimes it leads you to conclusions that are not, that you don't like.
And I mean, I'm presenting conclusions that I don't like, right? And I think that's, integrity in science.
It is the Thompson et al. 2025 study that you're a part of, is that the only study you're aware of that actually trials explanation versus no explanation or competing methods of explanation?
I mean, I wouldn't say that there's no other attempts, but it's, I would suggest that was probably in a combination with a method that elicited priors and posteriors from the same participants and had a large number of participants. I would suggest that that's certainly the greatest attempt to do the explanation. So you'll go, arguably, if somebody's presenting a table for converting from priors to posteriors, that's an attempt to communicate, to explain. But I would suggest it's the most effortful attempt, perhaps, to do that. So, but I was surprised. Lots of the studies just, hey, here's a likelihood ratio. Do you know what it means? No. So when I read those, I went, oh, okay, that's because there's no explanation. If I give them the explanation, that'll work. That'll get them to understand it. And unfortunately, it didn't. So.
Do you think there's, because I presume that kind of like in the study that you were part of, that when it refers to explanation, it's talking about explanation of a likelihood ratio. Is that correct? And I mean that in contrast to, well, let me just get at the question.
Yeah.
Do you think there would be a benefit to explaining not just the likelihood ratio, but explaining Bayes' theorem conceptually, the entire conceptual equation, not just the one term?
Well, I mean, effectively, I was explaining Bayes' theorem.
Okay.
So I didn't give them a formula. I gave them a set of scales of balance with different numbers of weights on each side. And so, like, if this represents your belief before the evidence is presented, we now multiply the weights on this side by the likelihood ratio value, and then we end up with these sets of weights, and that represents your belief afterwards. So I thought that was probably a good way. It's a visual. I think one of the recommendations was use visuals. So we used, it wasn't just me waving my hand like I'm doing now. We actually had pictures. So I also want to make it clear that I've done this when I actually testify in court, I do explain Bayes' theorem, using this method. I'm not trying to get the trier effect to apply Bayes' theorem. I'm explaining Bayes' theorem to them as a method to explain what a likelihood ratio means. And it would not be appropriate in my role as a forensic practitioner to try to tell the court how to reason. Right. So I'm very careful when I do this that I'm not telling the court how to reason. I'm giving you this to explain what the likelihood ratio means. And what you do I want you to understand it. What you do after you've understand it, that's up to you. That's not my business. So I think there have been attempts. There's so in England, Wales, many years ago, there was a couple of attempts to actually explain Bayes' theorem to juries, and to get them and give them calculators to do the calculation. And that went to appeal, and the appeal court didn't like that. But I think so I'm not doing it to try to get the trier effect to use Bayes' theorem. I don't think that's appropriate. I don't think they ever will. I don't think it's a reasonable explanation. But I am trying to explain Bayes' theorem in this kind of graphical way as a means of explaining what a likelihood ratio means. I don't really know of any other way that actually explains what a likelihood ratio means.
How about this? It's essentially a confidence meter. The higher the value, the higher the confidence and the support. You don't have to answer a question related to that, but that's just kind of like one thing I kind of fall back on. Is like, that's kind of the way I understand the likelihood ratio. Right. It's just the higher the value is, it just gives you the confidence that you have in the support. I mean,
it might work as a communication strategy at the sensitivity level. But I don't think it's going to work at the orthodoxy level.
Yeah. So one of the things you mentioned is the source level versus offense level elicitation of the posteriors. Is that something you would plan to take into consideration in future research? Is kind of like the particular level of the hierarchy of propositions that you would direct the research subjects to?
So, I mean, my plans would be to stick with source level. All the previous studies have looked at source level. There's lots of interest in activity level in research and maybe even in practice. I think we have a lot of problems at source level that we haven't yet solved. And so my focus is on source level. And I think, again, in looking at understanding likelihood ratios, I would certainly start by looking at source level. I'm not even planning to go anywhere beyond that.
Is that why you mentioned to minimize the case information? Is that kind of like a way to try to corral the subject to stay at the source level? Because my intuition is they want to go to offense level.
Yes, obviously, and but
you're
I think, and a lot of the existing research is, I mean, some of the existing research asked source level and offense level, and it's because these were questions that the researchers were interested in, right? So their research was not designed to answer my research question. It was designed to answer their research questions, and they were interested in perhaps source level and offense level, or even the ones that only elicited offense level, because they were interested in offense level. So they weren't actually trying to find out what the source level was. So either it's a big design flaw totally, or it's just a different design because they were interested in a different question. And yes, so because I'm interested in just the understanding of the likelihood ratio, I would want to strip away as much as possible other information. You need enough information to be able to elicit a prior odds, but I would be trying to keep that, to keep it to a minimum amount of information so that there's not other things potentially interfering. And then people might be using like reweight, for example, they might be using other information to reweight the likelihood ratios. And, or as I suggested, there was so much case context information that participants had already made up their mind before the likelihood ratio got presented.
Well, I could go on, but we're a little bit behind, and I know me included want to get to lunch. So thank you very much, Dr. Morrison, for that really interesting talk. We look forward to you completely solving this problem in about 4 or 5 years.
I need help. I need help with this. So if anybody can help, please get in touch.
All right, you heard him. Everybody reach out. He's easily findable at his website that I currently have open on my browser, which is jeff-morrison.net. Thank you very much, Dr. Morrison, for agreeing to talk to us today. Appreciate it.
Thank you very much for the invitation.
Yes, sir.